Okay, I can't talk very loud, so this is hard. So the first thing that we're going to do is like a warm-up number talk, so I just need you guys to think about the sum of 1 squared and the sum of 2 squared. So after you go through and do each one, put a thumb up so that we know that you're done. Okay, most of you have a thumb up. Can you maybe tell me any patterns that they see and what's going on up here? Okay. That's nobody's head, so that's okay.
It's adding 5 every time, so every time you do the square of the number, it adds 5 each time.
Okay, so the square, or 1 squared is
1,
okay, 2 squared,
4,
3 squared.
9,
You know what I mean? It goes up every time. What?
Okay, 4
You know,
squared,
yeah.
16,
and then 5 squared.
5,
Yeah, it goes 5.
25.
You know what I mean? 6.
Liz was on a good track.
Yeah,
though.
I didn't get it wrong. I got it wrong. But like,
No, you
plus
said
3
it good.
plus, yeah.
Yeah. So Liz says that she saw a pattern between like the increasing numbers. Does anybody want to elaborate on that? Any other patterns we see?
They're odd numbers in between them, so it's 3, and then 5, and then 7, and then 9.
In between 1 and 4?
Yeah. Well, yeah. There's 3 in between 1 and 4, and then there's 5 in between. Yeah, and then 7, and then 9.
Good. Does anybody else see any other patterns? Good work.
This will come back later. Don't worry.
Okay, so now we're gonna look at, oh boy.
So make a decision, and once you make a decision, you do auto zoom.
It's upside down.
So now, hold it still, like, so, yeah, like autofocus, like, but you have to hold it still if you're now hit autofocus, so you can't keep moving it.
Okay. Oh, okay. Okay, that's good. Okay, so as you're looking at, so look at this as this is one picture and then this is another picture. And we're gonna do noticings and wonderings. So in your group, you have 2 post-it notes on the end of your table. So you can take those and as a group, on one post-it note write a noticing and on the other post-it note write a wondering. As when you look at these 2 pictures.
Did they say that? Did anyone say that? Each of the answers goes odd, even, odd. I don't know if that matters.
Wait, but are we writing the pictures?
Yeah, we're in pictures. I was trying to
Are the 2 pictures related?
When you guys
Would be a
are
good
done,
question.
like, bring up your sticky notes so noticings are on this side, wonderings are on this side.
Oh wait, we only have 2 students.
a notice and a wondering.
There's 3 from second squared, from 2 squared to 5 squared. There's always going to be 3 Stephanie's 3 not so
Like there's always the same
amount of
ones. They're adding an extra layer. So that's how you're noticing. What is it? It's always the same squares, just more being added on to it.
yeah, another layer.
I see
And also
Right, so 2 squared plus 4.
I see them like in the negative. Okay, if you guys can wrap this up in about 30 seconds, that would be. And come stick your post-it notes on the board.
Does the two pictures correlate? Like, does the amount of shaded squares equal the amount of shaded squares that's on the second picture? Maybe.
What?
Like, if the amount of the, let's say, not so shaded squares equals the amount of not so shaded squares on the second picture, and if the, like, 3 squared, you know, the last layer, if that color, the gray, matches the same amount as all of that.
And the big image.
Yes.
Yeah.
So are the
If you guys can
all
start
the
bringing,
squares on the left
if you only have one,
add
that's okay.
together
Just
to all
bring
the
it up.
squares on the left?
Yeah.
I tried to like stop it! I just sounds dumb, I know. Just ignore that one. Don't read the negative space. Just say it better than I wrote.
I'll take it.
Are those things what it was? Thanks, John.
Thank you. Alright, so what I'm wondering is I wonder if the pictures have any connection. What do you guys think? Yes, they do. That's what we're getting. And do all the squares on the left-hand side add together to all the squares on the right side? We will get to that. We'll address your wondering. So, it'll come up, I promise. So a noticing is each square adds an outer L layer that is equivalent to the number that is being added to the step. So, does anybody want to elaborate on what was just said?
Can you repeat that?
Girl, read that to me again.
Each square adds an outer L layer, L, that is equivalent to the number that is being added to the step. So how about we focus on the L layer? Can anybody point out
Was
to
it yours,
Oh.
Melissa?
where that
It was
is?
our table, so we said like, so from 1 squared to 2 squared, we like, it's a +3, and so there's
Mhm.
3 squares make the L, and then a +5.
And so
5
you
make the
just
L.
pointed out also that it goes 3 are added, and then 5 are added, and then 7. Does everyone see that?
Uh-huh.
So now that's where it is starting to relate back to our number string that we just did. So there's 2 added to the number that was previously added, and then all that is added again. Catching on? Okay. So, and then all the squares on the left side are rearranged on the right side.
Whose was that?
Anybody can, if anyone understands that or wants to elaborate or explain. All the squares on the left side are rearranged on the right side.
So where do you guys see that?
Kim?
So one square has one fully shaded in gray box, and then you see that shaded gray box in like the 2 square, the 3 square, the 4 square, the 5 square. So that's 5 of them, and then there's 5 gray shaded ones at the very top of the tower.
Exactly. So she notices that this gray square is in all of these boxes, and there's 5 of them. So then there's darker lines here that you guys can't, I don't think you can see.
I can kind of see them, but maybe that's because I know the problem.
No, you can kind of
Okay,
see
so that will help also. So she sees these 5 gray squares all lined up right here in 5 rows. And then she's pointing out that this little L shape right here, this piece, is in the following 4 squares. So there's 4 of them. So there's 4 rows of the 3 boxes that were added. And then it continues with 5 boxes, and then 7 boxes. And then the last one, this one right here, is 9 boxes because it was only added once. So that's where these boxes can be seen over there. And then a new a new thing is added each time. So I think that what they're referring to is these big chunks. So do you guys see how there's 5 big chunks? What do you think that that represents?
I was distracting because I was whispering and talking.
Okay,
And that was
so
a bad teacher move, and I'm sorry.
There are where I put
I just
the
wanted to
blue
take a picture of you
lines.
because I thought I was really proud of you. Just being honest, you keep doing you. Keep going.
Okay, so there's 5 chunks here, and they gradually have less rows. And what do those 5 chunks represent? Jen?
The 5 numbers being squared.
Exactly. So if we went up to 4 squared, how many big chunks would there be? Anyone other than Jen? Good.
Sorry, Jen.
And okay, so now do you want me to do this?
Yeah, I'll try.
Okay, we're gonna look at a formula now.
I'm gonna write it.
Down. Okay. This is the formula, and we're going to talk about how this relates to this, but first we're going to talk about the formula separately, so you can forget about this for a second. But what do you guys think that n equals in this problem?
Ooh, that's a good question.
Well, remember these boxes. You can move them.
Figure number?
What?
Is it the figure number?
The figure number? Yeah, like specifically in this box that we're seeing, how many? There were, maybe show this again, yeah. Yeah. Okay, do you guys see that n equals 5 for this box right here? Agree? Okay. So I'm going to fill in this formula with n equal 5.
Sorry, we're trying to make
We're not good at technology.
all there.
It's
It's
all
not
this
all
way.
there though, so.
I would wait till Allison stops moving. When she makes a commitment to her location, then you can write.
Try the up. Is it all there? Go up one. Can you guys still see the
Okay,
equation
yeah,
in the back?
I think it's
Yeah.
really great. I think you're you got some perfectionist vibes going, and I love it.
Okay.
But I
Last
think,
time we were missing the little part.
Okay.
Oh, yeah. So,
okay,
good.
girl,
Let's do it.
I'm
Okay.
feeling it. It's fine.
So, write it out. Oh gosh. Is it done? Okay, do you see how I made n go up to 5 squared? Because n is 5 equals, oh gosh. Oh yeah. This pen is over. 2. Okay, that's a lot, but do you guys agree with this? Yeah. Okay, so when solving it, what would be the next step? Someone,
Shout it out.
what do you guys want to do next? Yeah. Yes. Should, like, let's focus on this side of the equation. So add all this stuff in the parentheses. Okay, you already did this with 1 squared. Shout it out.
1, 4, 9, 16, 25.
Okay, and this is still. So now, can someone use a calculator in your head add this?
Somebody's calculator in your head. Oh, that's somebody that is a calculator.
Oh
Somebody
no,
that
has it, or
I see a lot of devices around this place, man.
55? Yes. 5. Okay. And we're not going to solve this down further for a minute because we'll get to it. So now let's do this side. This. What is this? 2 times 5 plus 1.
Marvin.
You need a new pen. Those probably work better.
Yeah.
Oh, you can go to my blue box because I bring my brand new ones every time with me.
That one's good.
I'm just kidding.
Okay. Just writing over this. Okay, and this part. 1 plus 2 plus 3 plus 4 plus 5. Nice. And then div. So this is equal to this. And you can probably figure out what the answer equals in there, but we'll talk about it. So now, how do you see this formula in this box, or this whole thing? Talk about it with your group for a minute.
Which formula?
Oh, just this, it could be this or the top one. Just how do you see it in this whole area?
So on the green, maybe just I can't
See it.
super well. Where does that, so you said it equal
Yes.
another expression. What expression, in the green on the top, on the right? Yeah. What is that representing? I think maybe.
Oh, yes. So we're putting in n equal to 5. So in this was the equation that was given to go along with this, and so we just plugged in
Oh, okay.
5 because 2 times 5. Yeah.
Because that's the problem we were given up until n equals 5, so then that's what we're putting into the equation.
Okay.
Okay.
So now discuss. Makes sense.
Yeah.
Okay.
Yeah.
So now discuss where you see the formula in this. You can talk for a minute.
Okay.
I see like the left side, the 1 squared plus 2 squared. I see all that, but I'm sure I see it being equal to 5. Is that like the space around it? And then like the whole box is blank white box.
That's what I was. Yeah, I think so. Because the blank white box is going 1, 4, 9, 16, 25.
I get it.
I think.
1.
Yeah, that's right.
And 2.
Yeah.
It just looks like
So altogether, so 3 of them would be 55. Okay, like with the 3 different sections.
the first white section is 5.
55, the middle is 55, and the last is 55.
What about the 11 times 15?
So the first white box is 1, the second is 4, and then 9, and then
Yeah.
65. So that equals 55 total. And the shaded equals 55, and the other white is 55. So that would be 3 times 55.
Oh, right.
That's how they got the 3 times 55, but I don't know the 11 times. Or is it 11 times 15 the bottom or the top?
Okay. So what are some noticings that you found? Anyone?
Oh, Megan.
Yeah, so we were discussing where the 3 on the left side of the equation came from, and we were like, okay, so we already discussed that we can see the 55 in like the middle pyramid thing because it like corresponds to the picture on the left, but then also in the white boxes, like from the bottom up, it goes 1, 4, 9, 16, 25, and there's one on the left and one on the right, so there are 3 of the 55s.
Yes. Okay, so to elaborate on that for someone else, so you see that this is equal to 5 squared, this is 4 squared, going down, which is this part right here. And then, since it's timed by 3, there's this, this, and this, which is the 3 parts. This just looks differently in the way it's configured. It's not just 5 squared, 4 squared, it's encountering all of those.
And we know it's equal because we already talked about where these boxes are placed in that and how they're placed differently. So that's how we know that the 3 are equal.
Something else that you guys noticed.
What about the right side of the equation? Did anybody see anything there?
I'm just saying good questions. They're just so teacherific.
I mean, that ends up being an 11 parentheses multiplied by 15.
And where do you see that in the big square
Oh gosh.
or the rectangle?
In the big square.
Do you?
It's the parameter, at least if I'm counting right in my head, it's 11 across and 15 down.
Yes. So to go off of that again, there's 11 pieces. If you guys count, there are 11. And this was here, so we see in the beginning formula, it's 2n plus 1. And that's the width down here, if you can see that. And so if n's 5, 2 times 5 is 10, plus 1, 11. And there are 11 down here. And then this side, the length up there is 1 plus 2 plus 3 plus 4 plus 5, which you can see, like what Allison drew out, in the big lines, there's 1, 2, 3, 4, 5. And if you add that, that's 15. So 11 times 15 is this, and so the answer is 165. But so this 165 equals 165, and there are 165 total boxes in this whole square rectangle thing. So what does that tell us about knowing that 3 times 55 is 165, and that's how many total boxes are in this rectangle? What does that tell us about the sum of 5 squared plus 4 squared plus 3 squared plus 2 squared plus 1 squared?
It would be 165 divided by 3.
Which is...
She's like, I'm gonna calculate it.
Yeah. Yes.
Where did the 2n plus 1 come from?
This...
Am I jumping the gun? Is that okay?
Yes, go ahead.
Okay.
This is just from the formula, and this was labeled. So
Okay.
if you solve down the formula to the end, it's just width times length.
Mm-hmm.
And so in this,
Mathematical Association of America is saying, like, hey, what if this thing went forever? It's not just 11 by 15.
yeah, which is our next thing.
So when we did this, we set it up for n equals 5 because it goes to 5 squared, right? We already talked about that. The next kind of guiding question that we're going into is what would this look like if n equaled 6? So now we're going to focus on just this picture right here. So going through the equation, we want to know what it's going to look like, what changes in this picture when n equals 6. Does anybody have any ideas, hypotheses for what happens?
Like, how does this change in the look?
It would be 13y, right?
Yeah.
So good. Anybody else?
How about visually? How would these boxes change, the patterned boxes? What would happen there?
There would be one extra row of each patterned box, and then another different pattern on the bottom.
Liv, do you have something?
That's what I was thinking.
Okay.
Is everybody seeing that? Kind of understand?
So instead of having you guys all draw it, we drew it just so you guys could see this. Yeah.
Oh,
that's
yay. We gotta take a second.
But see, there's 13 at the bottom and one row of each. So like now instead of 5, this is 6, and so on. So you guys can see that, and it would continue on.
Do you guys see that? Okay. So we adjust the width increases by 2, and we see that because we add to each side, so we go from 11 to 13.
And the length increases by n. So now n would be 6. So now this is 6.
And so do you see the added boxes of this one is now a 6 by 6, which last time the big one on top was a 5 by 5, and now this one is the 5 by 5 in the 4, so it goes 6, 5, 4, 3, 2, 1. Are we all seeing that?
Mm-hmm.
So will this go on forever, based on the information that we've told you guys? Yes. Does anybody know why, or want to explain?
Because every time that you go up a step, up a square, you could just keep adding rows. There's never gonna be a time when you couldn't add rows.
Yeah. So basically, we'll just end up with a huge rectangle. Yeah. Eventually.
That we couldn't see till we get to heaven.
Yeah.
It goes on forever.